Here we are at the top of the hour. The boss man is gone today, so who knows what might happen on today's show. It might get a little crazy. And this is episode 19, right, Dan? 19.
Yeah. Next week
Tech
is episode
Talk Tuesday. Yep.
20.
Next week is the big 20th anniversary episode.
Mm-hmm.
And today we're going to be talking about wireless two-wire. And I know that I sent out an email yesterday. I tried to hook everyone, and so far attendance is proof of that. And what we are going to talk about is actually wireless two-wire. It might be a little bit different than you're thinking about, and it's actually something that is not brand spanking new today. And so It's technology that we've had, that we talk about, and that we've actually talked about here on Tech Talk Tuesday. But we want to make sure that the concept is driven home, that you guys know how our two-wire works and how we are able to use it now in a wireless format. So that's what we're going to talk about today. For those of you that are joining us for the first time, you can catch all of our previous episodes on the Baseline YouTube channel, which is Baseline Web Training, all one word on YouTube. All previous 18 episodes are there, as well as a lot of Dan's awesome new training modules that he's putting out on YouTube. And yeah, again, next week is the 20th episode, and we're going to talk about tools of the trade that are helpful, not only in irrigation, but also specific to Baseline. So would love to have you join for our 20th episode. I think, cool. Dan, with that, let's kick it off into wireless two-wire.
Nice. Yeah. When we came up with the idea of wireless two-wire, I'm like, what the heck are we talking about? Well, I really like the approach that we often take at Baseline. It's like, not what is the technology, what is this cool gee whiz technology, but what's this problem you're trying to solve, or what's the big question? So the big question is, how do we connect remote zones and sensors, bring them into our system, and manage them all together? That I think it's like, so wireless two-wire is one of the ways that we can do that. So we're talking about installing battery packs. Well, man, you can't manage everything all together. Trench wire, well, that's not always practical and sometimes often expensive. So today we're going to talk about how to extend the reach of that wireless connection through substation and wired through powered bicoder. So we'll take a minute, and I wanted to show you those devices. So this is a panel for the substation, right? And what's really fascinating about this is I've just pulled the panel out, and I have a controller in my office that I switch between a controller and a substation, because this is the brains of the controller. This fits all of our standard controller boxes, right? Because it's just hinges, it's in, and same power board, same transformer.
Yeah. And one of the things that is pretty awesome about, if you think Baseline as a platform, under the hood, that control panel being the hood, is the boards that drive our products, the two-wire boards, the conventional boards are all the same between 1000 substation, 3200. So for replacement parts, and even the modularity of maybe starting with a 1000 and converting the system to a 3200 with substations, all that's possible without removing the entire control box.
So the other component we're talking about is a powered bicoder. So powered bicoder is the way that we address conventional wire, but it also, off to the side, we can pick up two wire. So I can run, this is a 24 zone powered bicoder. So I can run 24 zones conventional, and I can bring up the remaining capacity, whatever my controller can handle or my device can handle, via two wire. So I can run to it. So those are the two really components we're going to be talking about today. So with that, I'm going to share my screen and show you what we're talking about. So here's my first site that we're going to look at, and I think this is the simplest way to look at it. So here on the left, I've got a base station 3200, and this base station 3200 needs to connect to a network, or needs to communicate, because we're talking device to device with our wireless two-wire. And the other device we're going to connect to is a substation. Ethernet radio seems to be the most common for these kind of configurations, but ultimately we're talking about connecting to a network and communicating to that device. So lots of other ways we can communicate. People have found that directly device-to-device radio is probably fits really well.
Mm-hmm.
So here we're going to have both of those devices connect to that same network, and then they're going to talk directly to each other. Now, once we've done that, the base station, or the substation rather, is a wireless extension of the base station 3200. So I go into the base station 3200, send a command. It tells either wherever that zone is located, whether it's physically located on the base station 3200 or physically located on the substation. It doesn't really matter. The base station 3200 can control it wherever it is.
Yeah, and one of the things too that I usually use to describe how this works, and I think at least half of the people on this call probably know how our two-wire works in terms of the search and assign capability and how that is so powerful and why that is so awesome. It works the same way, right? So if you hook two-wire up, like you have in your picture here, zones, and you want to bring those into the 3200 controller, you turn the dial to search and assign, you run a search, it uses the wireless protocol, but it's still that two-wire search and assign capability that brings those into the controller.
Right. So on this site, they had a main line that ran on both sides of the roadway, and the main line ran underneath the roadway, but they didn't have a sleeve to get wire to the other side. This is a great solution. This is one reason why, probably the main reason why we invented this, was to get across a roadway or a driveway, maybe get across a parking lot when it wasn't practical to trench a wire. We're going to talk about some other reasons that people would use it. But this also, as Andy talking about the extension or the wireless search and assign, I can bring any device into that substation, and now it's part of the 3200. So I could bring a flow sensor, a master valve, a soil moisture sense, a pressure, anything that we have could be installed on that substation, conventional or two-wire, and it brings it back in, because each of our substations can have a two-wire or conventional wire attached.
Yep, that two-wire port, that red and black two-wire port, is a standard on all baseline products. And so if you think of that substation, it has that two-wire port, and that means you can plug any two-wire device right into that substation and search and assign from the controller.
Right. So we're talking device to device, but there's another way that we can have these communicate. And let me change my slide here. So the other way to do it is to do device to cloud. So the only thing I've changed on this one is, instead of talking directly to each other, the base station 3200 has will subscribe. So there's subscription involved to baseline cloud networking. So the controller talks to the cloud network, the substation talks to the cloud network, and that's how they're going to share their information, is in that cloud network. So when I want to run zones attached to the substation, I'll send a command to the 3200, and it's always on, so it's connected to the cloud. The base station, the substation, is always connected to the cloud. It receives the command via the cloud, and the zones run. Mm-hmm. So this setup works really well when I can't connect to the same network, or this really opens the door for cell modems. So now cell modems are certainly easier to set up than radio networks, and pretty darn affordable. So I can use a cell modem in each of these devices, connect to the cloud network, and work with them.
Yeah. Yep. Not every site is a fit for radio for various reasons, either distance or obstruction. And so now that we're able to pipe this connection through the cloud, the substation can be located anywhere.
Right. It's going to bring us up I like where you're going with this one. I'll show you on the next slide. I've also found that sites where they have trouble connecting to the network, and it could be as simple as the IT department just doesn't get it, right? So if you're on a campus or a school or a city, and the IT department is not cooperating and they don't work with them, fine. We're just going to connect to the baseline cloud network and share information, and we won't mess around with the IT department, or you can just avoid them. So we found people that are just troubled by them, and this is a great solution for that one. So Andy's letting on to the next one, right, is how this opens some really interesting doors on how we can expand this. So if I can connect to the cloud with my device, there is no distance separation, right? Radio has a distance, but a cloud doesn't. If I'm connected to the cloud, my base station 3200 is connected to the cloud. My substation is connected to the cloud. I can have other substations on the other side of the city, on the other side of the site, across the state. I mean, you could have them across the US. It's really the how you could connect them. You're almost unlimited.
Right, right. And just to kind of bring this back home, remember, you turn the dial to search and assign, and you click search and assign just like you would if it was a traditional two-wire system. And we have that same capability of two-way communication out to the substation and then out to its devices and right back to the controller. Exactly the same way. We've just now made it a wireless system.
Yeah. Now, I'm showing 3 substations on this slide. We can actually have up to 8 substations connecting back into that base station 3200. They could all remotely dial in, somehow connect to the cloud, or radio connect back. Now, the other limit on this one is since it's connecting back to the base station 3200, the base station 3200 is the controller that runs all of these. There's 200 is 200 zones on that controller, so that's the limit. So this really works well with pocket parks in cities. So they've got little tiny pocket parks with maybe 10 zones or 15 zones. So they can bring them back into a base station 3200, and they could be 5 miles away on this side of the city and then 10 miles on that side of the city. It's bringing them all together into one controller because the base station 3200 can handle 200 zones. Nice. So I think this was kind of a cloud networking really opened this up and made this very practical. With the radio, it was a little less practical. This is very, very practical. Substation can be used to extend the two-wire path. So here we've got zones in multiple places along this two-wire path, and what can happen is there's a finite limit to how far you can run a wire. It depends upon the size of the wire, right? Generally 5,000 feet, could be up to 8,000 feet if you have a larger wire size. And people have been known to go over that limit.
Either because they made a mistake in the beginning or the site continued to grow and they didn't pay attention to the limitations as they continued to add on.
Right. So there was a contractor that I heard of that it was a new installation and had run the wire too long, even though it was designed properly, and they just probably the way they had to route their wire, and it was really going to hurt them. Well, we had a solution for them that was able to work out. And what they did is separated it into 2 wire segments and then connected them virtually or electronically through substation and baseline cloud networking. So they have definitely extend that reach of the 2 wire. So instead of going that 5,000 or 8,000 foot, they could now go 16,000 foot or 20, have a larger amount of wire in there.
Right, right. And, remember that some of the limitation is built on the single transformer out of the controller. So by adding this second substation, now we have that same distance specification that was in the controller, moved it into a substation, and you can do that up to 8 different times. And so in theory, if you had 5,000 feet of wire on your controller, you could have 5,000 feet of wire on substation 1, and again on substation 2, and you could have, I don't know what that 40 or 45,000 feet of total wire. You'd likely run out of zones before you'd reach that distance, but it's certainly possible.
Maybe when we get to Phoenix, where they don't have dense planting, but or Texas, right? But yeah, I'm showing the wire running off the edge of the screen, and that could go, like you said, another 5,000 to 8,000 feet, depending upon the wire size, and then repeat it and repeat it and repeat it.
Yeah, and this can be used for design intent. So engineered and configured this way from the beginning, or used to extend a site that was existing that may have reached its load limit on the system.
Right. Yeah, what's kind of fascinating about this is when we first invented this, we, as a team, we thought it was going to be used a very specific way, and then as we started coming up with some really interesting use cases, and like, oh wow, we can be using it all these other ways, and this is one of them. So I'd be remiss if I didn't talk about wired to wire. So powered bicoders is part of this problem solving tool, the toolbox that we have here. So in this case, a powered bicoder is where we have a base station 3200 or a base station 1000. And that's kind of what's nice is either controller will work with this one, where the substation is an extension of the base station 3200 and not the base station 1000. So here I've got a base station 1000 or 3200 connected to a 2-wire path and zones attached to it. Somewhere on that wire path, I've got a powered bicoder connected that is receiving that 2-wire path, and then it can run conventional zones or other devices out there. So now that powered bicoder that we saw earlier, right? This device is just another 2-wire device on that wire path. Now, some of the things that are cool about this is it works with either controller. There's no networking involved. And it works really well when you have an existing wire path or a new 2-wire path, and you can bring that in. So this will allow you to bring devices back into that controller, but it's in a wired method.
Yeah. I'm glad you're talking about this, because this goes back to the very beginning of Baseline. Baseline's had this powered bicoder technology essentially since day one. When you think back to the first Baseline 2000 product, and some of our users that have been with us a long time know this. Others that are new don't know that this product exists, and it's in the fundamentals of how Baseline operates and why we call that a powered bicoder, because all those terminals are 2-wire addresses and they're addressable. So this is a great way to think about taking this technology and making it wireless. And that's sort of what the substation does, makes that technology wireless.
Right. Absolutely. So there's a couple of different options or different ways we can use powered bicoders. So you could use them in a new cabinet. So with the red wire on the left, or my left, is a 2 powered bicoders in a cabinet picking up conventional wire. And so that we've got a 2-wire coming in there. I like your comment that you made when we were doing a practice. It's like, well, how do I know what that is?
Right. Dan's showing me this picture of these red wires, and he says, this is a substation. And I said, how? Maybe it is, maybe it isn't, because what we're looking at is the same boards that are in either a 1000 XR48, a 3200 XR48, or the substation XR48.
Yeah. Or it could be just powered bicoders in a cabinet. Mm-hmm. Any way of those, right? So, but you can buy them in just a cabinet. And the cabinet will carry up to 48 zones. And if you need more, you could run an additional cabinet. So you could also use powered bicoders to retrofit into an existing cabinet. So in the center, I thought this was pretty fascinating. There's 3, actually, I think there's 4. I cropped it out. Maxicom pedestals. And what's kind of cool about those Maxicom pedestals is they're stainless steel. So they're fully robust, right? They're not going anywhere. They've got a power supply, and the conventional wire is coming into that one. Well, let's make use of that. Well, we have what we call a PCK. It's essentially that power bicoder mount with a back mounting plate. In this case, they used the existing transformers, they connected to the existing field wire and mounted that in there. Now, you need to have a little bit of engineering chops in there to do some basic mounting, but it's a great money-saving feature on that one. Mm-hmm. Now, with a power bicoder in each one of those 3 cabinets, they still need some way to connect those wires together. So one way would be to get a big 3-inch pipe and run a loom of 150 wires all the way back to the first one and put all the power bicoders in one. Well, that's kind of annoying. Well, all they had to do was, in a 1/2-inch conduit, run one section of 2-wire to connect those power bicoders together and daisy chain them together, because the power bicoder is just another 2-wire device. So they didn't move any wire around. They just extended it with a small section of a little 3-foot section of 2-wire. Mm-hmm. And then the last one on the far right is a power bicoder inside a Baseline controller. So this looks like this is my 1000 controller I have here in my office with a power bicoder in it. But we've always had this option, right? So you could buy a base station 1000 or a base station 3200 with a powered bicoder in it, And that's how you would bring two-wire technology to your conventional wire site, because all of our controllers are two-wire controllers, but this is how we would interface with that conventional wire and not have you have to replace the wire. And then, of course, right, remembering that we have a two-wire terminal on this board as well. So if you ever expand or want to do any additional work or put in extra sensors, you can put those on the red and black terminals and connect into the two-wire. Cool. I've got two sites that we're going to take a look at that are some very, very real world. And actually, we saw these in previous Tech Talks. These are sites that Tracy shared with us.
Mm-hmm. Yeah, and I think that it's good to reiterate some of the stuff we've already talked about for repetition purpose, but also many of you may understand how we were able to tackle these big, complicated sites that we talked about. For others, it may have just gone right over. And so we wanted to bring sort of what we're talking about today with our wireless two-wire back to some of these sites that we've already discussed to make sure that we all know how this technology works in the real world.
Right. So this site, and this is actually the site I've been using earlier today, has 5 different water sources. So 5 water meters, domestic water meters spread across this business park. There's one base station 3200, that's the pedestal. And then they've used 4 substations that are connecting back to the base station 3200 on networked via radio. And then they've also used 6 powered bicoders out in the field to connect to conventional wire. So they've kind of got the mix and the match of everything. So they've got base station 3200, the substation, and power bicoders. They've got it all.
Mm-hmm. Yeah, it's a great way to consolidate controllers, right? Because this used to be 5 and now it's 1. And then just for repetition, these are all search and assign devices. So at that controller, turn the dial to assign. When you click search and assign, it goes out wirelessly and brings back into the controller all the different devices that may be connected to those substations, which could be your flow sensors, pressure sensors, decoders. All the two-wire devices are search and assignable in that wireless fashion.
Right, right. The one other site that's another real world site that we've seen before. Here, this one is a little different. We've just got one water source on this site where they're pulling from that lake, but they've got 3 base station 3200 controllers, and those have radio in them. They've got 14 wired powered bicoders, so that's how they're connecting to the conventional wire. And because they have 3 controllers and 1 water source, they're using a flow station to manage it. That's the only reason they needed the radio, was for the controllers to communicate to the flow station. And so that yellow grouping, that yellow controller with the yellow power bicoders, that's connected actually via a 2-wire path. And that's how they're bringing that conventional wire back into the base station 3200 and communicating amongst them back and forth. Because, right, the 2-wire path is 2 things, right? It's carrying the power for the zones, and it's also the communication wire for our controller. Mm-hmm. That green controller is zone standalone, and then the purple grouping is another controller and another grouping of power bicoders. And then the flow station is the one managing all the flow across all of those controllers.
Mm-hmm. Yep. So again, for sake of repetition, on the purple arrangement, when you turn the dial to assign, you do a search and assign, and it pulls in all those devices connected right into the controller.
Right. And I think the reason Tracy used 3 different controllers is because the station count was quite high on this site, right? So I think he is upwards. He's just under 600 zones on this site, really close to it.
Yep, so. Yep. Because the limitation is the limitation of the 3200, that 200 zone count, 25 soil moisture sensors, 8 water sources, 8 points of connection, et cetera, et cetera. As soon as you get out of that, then you have to add additional controllers and then a flow station if you're managing the flow between.
Right. Right. Beautiful. Okay. Well,
a couple questions.
Good. I was going to say, we don't have Chris here to manage our questions.
Yeah. So let's see. This is a great question as it relates to the substation. Can we use a solar powered 3200 with a substation? So there's basically 2 different questions, because the substation is connected to a 3200 wirelessly. It's important to remember that with solar, we're talking about two wire, not
Only
two wire, DC latching, two wire devices and a true two wire. So non-conventional wire.
Right.
As long as it is a true two wire, non-conventional wire, the controller can be solar and the substation could be solar. You just cannot operate the AC solenoids. It needs to be a DC two wire.
Right. Right.
And then we have, I guess, a question that is similarly related. How far can a valve be away from the bicoder using, say, 14.1? So I believe it's 150 feet from the little black decoder module to the solenoid. I think that's just standard 18 gauge. I'm not sure, but
yeah, the only thing I'd probably say on 150 feet is accurate. So if I had a 4-zone bicoder and I wanted to extend wire to the next valve, the only thing I would caution on that one is extending that number 14. You're opening it for damage, right, along that wire. Well, because it's not along the 2-wire path. If it was along the 2-wire path, you just drop in another decoder and then give yourself more options. That was probably the only caution I'd have on that.
Yep. Mm-hmm. Any other questions for us today?
Let's take a look.
Are, I would say, preferably related to topic.
We'll take what you got, but yes.
I'll mention again that the way that the wireless two-wire, the substation, comes into the controller are zones of the system. And so when you take 5 or 6 controllers and you're going to consolidate them into one, it's important to remember that those existing 24 zones now become zones of the 3200. And right. I see some people that use labeling in the zone descriptions to help remember. They may say controller B, zone 1, controller B, zone 2, controller B, zone 3, so that when they reference those zones, either in quick view or in programming, they can remember that zone 56 used to be controller B, zone 4.
Right.
Just as a kind of a tip.
And to that point, and forgive me if I'm repeating what you just said, but when you search for those zones and you bring them in from the substation, you don't know that they're on a substation. And
right, they have an address. So all you're seeing is either the decoder address of the black decoder or the serial number of the screw terminal, the V, right. The V right. serial number. Mm-hmm.
So one of my thoughts and something that I promote in my training rooms is, if you want to know where those wires are, so later on you need to do wire work, for example, is you can put a unique name on there, and it might be just SS1 for substation 1 and SS2, and then put your naming structure that you might put on for your substation.
Yeah.
And that'll give you a clue as to where it is.
Bigger the site, the more names and descriptions are super helpful.
Yeah.
Yeah. Yeah. Especially for troubleshooting when you call support or you're talking to one of us. It's nice to be able to use real world names instead of decoder XYZ.
Right, right.
So cool. I think, Dan, that we're coming right up on the 30. And again, next week is our 20th episode. Chris said we were going to do some giveaways, so let's hold him to it since he's not here.
Right.
For those of you that may have joined us on every episode, and I think there are some that have been with us.
Might be our core.
Number 1.
Right.
Yeah.
So next week we'll be talking about tools of the trade, tools that you want to use for 2-wire systems and definitely for baseline systems. There'll be physical tools and maybe some electronic or other tools. So
cool. All right, guys. Have fun out there. Be safe. And we will see you next week.
Okay. Take care.